Okay, in this unit, we are going to be looking at probability and statistics, and we start out with some statistics. Now, some of this is a refresher, but still, I'm sure you probably will need it. So we've got the measures of central tendency to start. That's fancy for mean, median, mode, and range. Here are all the definitions. So the mean is the average. To find the average, you add up all of the numbers together and divide by how many pieces of data you have. For example, test scores. To find the average test score for a class, I add up I add up all of the scores, what we all got, and then divide by how many students took the test. The median is the middle. So the middle number, you order all the numbers from least to greatest, and you find the middle by actually working your way in until you reach the actual middle, which sometimes ends up being a data value. If you have an odd number of numbers, then there will be an exact middle. But if you have an even number of numbers, you'll have a middle between two of them. So to find that middle, you add them up and divide by 2. The mode is the number that occurs most often. So a number that pops up the most would be the mode. Now you can have more than one mode. You can have no mode at all if every number occurs once. It really depends. And then the range is just the difference of the largest number minus the smallest number. So in example 1, we have the ages and years of employees at 2 different companies, Company A and Company B. They want us to find the mean, median, mode, and range of the ages of the companies or the employees at both companies. So to do that, what you're going to do is follow the directions here. So for Company A, to find the mean, you are going to take all the numbers, add them up. So 22 plus 30 plus 31, 36, 38, 46, 49, and 52. So I'm typing all of these in my calculator, and when I type them all in, I hit enter. I got 304. There's 1, 2, 3, 4, 5, 6, 7, 8. I'm going to then divide 304 by 8, and the mean for Company A is an age of 38. Median. To find the median, you actually have to find the middle number. Now, thankfully for Company A, all of the numbers are already in order for us. That's great. We have 8 different employees here, so the middle is going to be actually not a data point. It's going to be right in between 38 or 36 and 38. So technically to find the middle, I know this one's kind of easy, it's just 37, but to find the middle, you can add 36 plus 38, then divide by 2, and you would get 37. The mode is the number that occurs the most, and for Company A, every number occurs only once, so there is no mode. I'm going to put like not applicable. Don't put 0 because 0 is a number. And the range is the largest number, which is 52, minus 22, and that would be 30. Okay, for Company B, same idea. 48 plus 55 plus 67, 70, 75, 77. We still have 8, so when I take this 528 and divide by 8, I get a mean of 66. The median, the numbers are already in order for us, which is great. The median is going to be between 67 and 69. That's going to be 68. The mode, the number that occurs the most, 67 occurs the most. And the range, 77 minus 48, is a range of 29. Now for the questions. The Keystone will maybe sometimes have you find these types of numbers, but more so than often what will happen is they'll ask you questions like below. Like, what's the difference between the means of the 2 companies? Is there a difference in median ages? What can you conclude? The Keystone loves to put that kind of stuff on there. So the difference between the 2 means, so if we're looking at this, the mean of Company A is 38, and the mean of Company B is 66. The difference between 66 and 38 means subtract. That's going to be 28 years. The difference in median ages, so the middle, 68 minus 37, is 31 years. What can you conclude about the companies? Now, I didn't realize it when I was, doing the calculations, but Company B definitely has an older population of employees. if we're looking at the mean of company A is only 38 years old, while the mean of company B is 66. That's pretty old, considering, the mean of company A is only 38. The same with the median. So the median 37 versus 68 is another, indicator that company B has older employees. But the range ends up being fairly simple. The range of company A was 30 years and the range of company B is 29 years, but company B is just older. So I would say what we can conclude is that on average, because that's what the mean is, company B has older employees. All right, moving right along. Now, mean, median, and mode, the measures of central tendency, are all different things that we can use to analyze data. The Keystone loves to have you analyze data. The mean is most popular, I feel like, when everyone, takes a test. It's always like, oh, what's the average? It's useful to compare all of the numbers. It incorporates every single number, but it does get affected by outliers. So like if I have a class of students I give a test to and everybody does fairly well, but one person maybe was absent a lot, didn't really do the makeup work, and failed the test, that outlier will then pull the mean down, and it might not, be a good representation of everybody else. The median is the middle, so it's not really affected by outliers because it's just like the middle number. So that's nice because it doesn't, have the outlier effect, but it's not used as often as the mean because the mean does incorporate every single number. The mode I feel like is not as popular to use because it's just kind of random, like what number occurs the most. But sometimes, you need all of the numbers to really be able to conclude something in a set of data. What is an outlier? It's a number a lot larger or smaller than the rest. So in this example, we've got apartment rental charges, and they want us to find the mean of the rentals. So if we're looking at all of the monthly rents, here they all are. We would add these all up, and they told us there's 10. We would divide by 10. This question, which I'm not going to take the time to really do because it's pretty simple, the mean is going to be higher than what a lot of the apartments are being rented for. And that's because we have a couple of significant outliers, like this apartment, $3,600 a month, this apartment, $1,800 a month. Both of these numbers pull up the monthly rent. But if we look at the other numbers, they're all just in the hundreds, 480, 360, 600, 480, 720, 600, 480, 540. So they're all 700-ish or less a month. And then we've got this big 3,600 and then also large 1,800, which significantly pulls the mean up. So sometimes the mean does not fairly represent data because of outliers. That's what this problem is trying to get us to understand. The next thing I want to cover is line plots. So line plots are definitely going to be on the Keystone. You just have to understand what it means. So example 3, we see a line plot which they either uses X's or dots to represent the data points. So in example 3, we have high school debate team members. We've got the ages 14 to 20 listed here, and then an X over 14, 15, 3 X's over 16, 2 over 17. And then we've got the college debate team members as well. And it says right here, each student or each X represents one student. So what they want us to do, it says which measure of central tendency is easiest to determine from a line plot. So if we were looking for which measure is the easiest, definitely not mean, because no matter what, you have to do some calculations. The middle could be, I guess, kind of easy, but the easiest is definitely the mode. So the mode is easiest to see because it's just going to be whatever number has the most X's. The range of the high school team members. The highest number is 17. The lowest number is 14. 17 minus 14 is 3. The range of the college members, 20 is the highest number. 18 is the smallest number. The range is only 2 years here. And then find the median age of the high schoolers. My suggestion would be actually to write out the numbers rather than try to leave it in its actual line plot form, just because it can get kind of confusing to find the middle when you leave it there. But when we're finding the median age here, we've got 1, 2, 3, 4, 5, 6, 7. So we're going to have exactly a middle. The median age would be 16. Okay, so next we have a box and whisker plot. So a box and whisker plot is something that we use a lot to analyze data, to organize data as well. A box and whisker plot, the definition is basically you're going to take data, so it's a data display. That orders the numbers into quartiles. Quartiles meaning 4. So of course, a box and whisker plot has a box, has a whisker, but really what this means is we're taking all the data values and we're separating them into 4 different sections. To do that, we need 5 numbers. The minimum value is the smallest number. The maximum value is the largest number. The median, we already know, is the middle number. So this is the order I do it. Smallest, largest, then the middle. And then the lower quartile, also known as Q1, is the middle, so it's the median of the lower half of the data, which is all the numbers under the median. And upper quartile, also known as Q3, is the median of the upper half. So the quartiles, like I said, we've got Q1 and we've got Q3, and the definitions are above there. I already put that up there. But interquartile range, the Keystone loves to put questions like this, also known as IQR, interquartile range. What you do is you take the third quartile, Q3, and subtract Q1. So it's a range in that it's a subtraction problem, this number minus this number, but it's not the biggest number minus the smallest number. It's the range of the quartiles. So we're going to do one together just to make sure that we understand here. We've got the resting heart rates in beats per minute of a group of people, blah, blah, blah. Draw a box and whisker plot, and then answer the questions. So most annoying part about this is having to order the numbers if they're not already ordered for you. So we've got 50, and then 55, 58, 60, 62, 64, 68, and then 70, 72, 76, 84, and 92. So I always like to go back through and make sure that's right before doing anything else, but I'm pretty confident that I didn't skip anything. And then what we would do is list the numbers. So the minimum is 50. The maximum is 92. Now we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 numbers. So the median is not going to be a data value. It's going to be between 2. So it's going to be between the 6th and 7th. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Oops. Wait. 1, 2, 3, 4, 5, 6. Oops, sorry. That was put in the wrong spot. The middle is not between 62 and 64. It's between 64 and 68. So to find the middle of that, now 64 and 68 are 4 away, so you can just probably figure out 66. But you also can add 64 plus 68, then divide that by 2, and you get 66 as your answer. That's your median. So this is the lower half, and the other side is the upper half. What we need to do now is find the median of the lower half. We've got 1, 2, 3, 4, 5, 6 numbers. The Q1, the middle of the lower half, is going to occur between the third and fourth number here. It's going to be 59. And then for the upper half, it's going to occur between the 72 and 76. That's going to be 74. So here are our 5 numbers. Now what we need to do on the number line thing below is at least start at the number that you need the minimum of, and then we need to go to at least 92, the maximum. So up to you what you want to do. Just to save time, I'm just going to go by tens here. You have to go by the same number for these little lines here. So 50, 60, 70, 80, 90, 100. Probably could have went by fives, but this is fine. The minimum is 50. I put a floating point above it. Maximum is 92. It's not going to be perfect. I'm going to put a floating dot around here. Median is 66, about right here. Q1, lower quartile, 59, about right here. Upper quartile, 74, about right here. So if you got 5 floating dots, and to make a box and whisker plot, your Q1 to your Q3 make your box. You technically are supposed to put a line down the median, and then you connect Q1 to the minimum and Q3 to the maximum. And then for the questions, what is the range? Well, we could answer that without actually having the box and whisker plot. We would just do 92 minus the 50, and we're going to get 42. Inner quartile range, we do 74 minus 59. That's 15. And then for the interesting ones, what percent? So the Keystone actually loves these types of questions. What percent have a resting rate less than 66 beats per minute? So what's super important about box and whisker plots is we understand that there's 25% of the data in this whisker to the left. There's 25% of the data right here, 25% of the data right here. So in the actual box, there's 50% of data. 25% to the left of the median and 25% to the right, and there's 25% here. That's what quartiles means, splitting it up into 4 equal parts. What makes it visually look like it's not equal is because the numbers are going to determine what the box and whisker looks like. If the whiskers are long, that's probably meaning there's an outlier. If the box is pretty small, it means a lot of the numbers in the central location are fairly similar. But for the percent questions, 66 is the median. So what percent have a resting heart rate less than 60%? That would be, less than 66 beat per minute. That would be 50%, because 50% of the data is to the left of the median. What percent have a resting heart rate of no more than 74? So no more than 74 would be anything 74 or below. That would be 75%. What percent have a resting heart rate between 50 and 59? Well, 50 is the minimum and 59 is Q1. That would be just 25%. And what percent have a resting heart rate between 66 and 92? 66 is the median, 92 is the max. That would be 50%.